Hi everyone. So this is the first section on learning Diva and other building simulation software. So today I'm going to introduce the how to use Diva in Mir project by showing some of the reference project I did. So let me introduce 4 different projects at first and then explain each way of how we use Diva in each project. First of all, we could use Diva. Diva is as I told you, Diva is the daylighting simulation project software, and we could use Diva to do the building design and retrofitting. This is the first project I did. I actually during this project, I did a bunch of the analysis on the building and the around building and as well as the climate condition of the building. And then after I did specify all the materials used in the current building which I want to renovate. And later I did the modeling of the building, which is the on the left side and the bottom. I did the actual building modeling and then see the indoor condition. So as you can see the 4 different pictures on the right on the bottom, and then we can see a very dark place in interior space. So the aim is to increase the daylight penetration rate and ratio inside of this interior space. So in this project I did introduce some of the light cores, as you can see on the option 2. So this is the quite huge intervention because we actually dig a hole on the building slab and then cover this as a glass and then simulate the environment. But by doing this, we see the daylight area in annual increased from the 12 to 50 at the end of the final option. This is the comparison between each option. So as you can see, the third option, by introducing the light core on the right, we see more bright indoor area. Also, we could by using Diva, we could test the different types of window material to see how much reduction of the glare issue we could get and other stuff. The second project is by using Diva, we could do the facade and shading design, because the shading control is very critical and very important to make sure the indoor daylight and the occupants indoor eye comfort. So I did a couple of study. Actually, in this project, we took the rear building and found the problem of the late afternoon glare issue. So in late afternoon glare issue, to reduce this issue, we need to introduce some of the shading device on the southwest facade. This is the problem analysis. So actually we built the actual model inside of the software and then try to simulate several times in different times of the day to see how much glare actually penetrated into the work plane. And then we try to implement the different heights of the shading device and the different angles of the shading device and then see the optimum value to reduce the glare issue. So as you can see on the right photos on the top and the bottom, and the pink area is actually the overlit area. Overlit means that there's a huge possibility to get more glare problem in human eyes. So to reduce, because in that section we have 3 different workstation to and then has occupant it's all day. So we need to reduce that amount of the glare on that specific work plane. So in that case, we also can use Diva. This is the shading strategy we did. And we did also test a couple of different options for the different geometry. And then try to see the impact of this unique geometry patterns So we actually run the Diva again to see the different result. So on the bottom left is the like original case, and the middle is the when we suggest the shading device only, and on the right one is when, like if we suggest like more advanced version of the shading device which has some patterns and like translucent like layers, then like we could get like reduce the glare on the work plane, as well as also like quite scenic views and pattern, which is pleasing. Additionally, this is a direct glare simulation by using Diva. In the project 3 is like also we could do the context building design, which means that like unlike the previous two project, because that two project we already have it has the given building geometry, right? But like for this one, like we don't really have the like given geometry yet and the context, so we could move around our building geometry following based off on the simulation result of the like schematic design building. So this is the real radiation analysis by using Diva. And for this project, we shifted this whole building into like several direction to maximize the daylit area on the like critical facade. So, you know, as you can see in here, like option 2 gets more daylit area on the like southeast facade than option 1, and the like both option 1 and 2 has more daylit areas than the original layout. This is the result of the spatial daylight autonomy. All these detailed information and the method we could use for gauging this performance is like we're gonna talk about the next lecture. And this is the parametric simulation. Like we have like a bunch of different alternatives, and then like has different options on the given context. So by doing this using Diva, we could like optimize our location of the building geometry according to the like contextual buildings already built in the site. Finally, this is the last one. I'm gonna introduce the LEED well concerting project, because like, you know, by increasing the attention in the well-being and the comfort and human eyes in building, so we need to you know, meet the criteria with, from the LEED and WELL standard to approve the green building certificate or some relevant tax reduction. So in this case also we could use Diva. We could use Diva and then like specify all the material and geometry on the and so on for like meet to criteria or LEED and WELL suggested. And this is like kind of brief introduction of the threshold to like when we achieve the more than at least 55% of the SDA the whole year, we could get the 1 credit in LEED. Also, like if we has like less than the 10% of the ASE, we could get the LEED standard for the daylit. So like when we assume like we have already the building and the context as well as all the consideration like including materials and so on, we could do conceptual dynamic shading test and no shading test, and then see the difference between two conditions. Like we see the like amount of the daylit area like reduced, and then also the spatial daylight autonomy area also over like 58%, which is like over 55. So it's already satisfied to get the credit from WELL. This is another example we run. So far I explained to you about how we use the Diva to actually incorporating the real project we could have as an architect and building building design consultant. In next lecture and next lab session, like we're gonna learn actual use way of using Diva. But like I hope you guys understand like the concept and general idea of the Diva software by seeing this slide and lectures. Thank you. See you later.